what we have learned. Well, for the first couple of exercises, we learn how to factorize. Okay, how about expand? The first exercise is expand. Like, I don't really care about expanding, so we can do that. So for factorize, we have, if there's two terms, and also they are subtract each other. And we have 4 terms. Okay, so for 2 terms, we have a squared minus b squared, the difference of perfect square, factorized by that. We have 4 terms, we have grouping. And the very first one we need to think about is common factors. Okay, that's the first 2 exercises talk about. We can see common factors. We can, for grouping, we can go a squared minus b squared. For difference of perfect square. That's the first 3 techniques we learn how to factorize. And then after that, we go for quadratic equations. Like, we go ax squared plus bx plus c. I use cross multiplication. So like a, b, c, we have factors of a and a, c and c, cross multiply that and adding them, trying to give you the value of b. They're trying to give you the value of b, like that's the cross multiplication. And I said not all of that can be done by cross multiplication. And it's not really connected to chart yet. I'll just talk about what we have learned. Like later we'll put everything together. The next thing we learned is not all of them can be done by this method. For example, they can be factorized, but they can't, like only part of it can be factorized by that way. So the third one we learned is what is called the completing square. Okay, the next one we learned is completing square. And completing square can tell us whether it can be factorized or cannot be factorized. Okay, can be factorized looks like x minus h squared minus k. And cannot be factorized looks like x minus h squared plus k. Well, they can also have a coefficient in the front, like they can have a. It's not always a single x. So if we have ax, we take a as a common factor. So when it looks minus a constant, then it can be factorized. When it plus the k, like plus 2, it can't be factorized. And then we learn for solving. Okay, solve quadratics. Okay, we solve for quadratics. So when we solve it, I said there are 3 steps. Like first of all, I need to make it ax squared plus bx plus c equals to 0. And second is simplify and factorize. And step 3 is non-factor law. Okay, so that's the 3 steps what we should do. And also we know if cannot be factorized, we'll have no solution. Okay, we learn from that time, if cannot be factorized, there will be no solution, like I can't solve. If we have perfect square form, okay, if we have perfect square form, we will have one solution. Okay, we have one solution. What's the perfect square looks like? X minus h squared equals to 0. That's the perfect square. There's no k values, which also gives you k equals to 0. There's no k values. And that's the perfect square form. So dot point. And if we have two distinct factors, we'll have two solutions. Okay, we can factorize and there are two distinct factors, then we will have two solutions. Okay, that is solving quadratics. Okay, solve it by factorize. Okay, solve it by factorize. Like we have two ways to do it, factorize, and then another way like this is done by factorize, and the second way we can do it is quadratic formula. Okay, so quadratic formula is ax squared plus bx plus c equals to 0. We can do that by x equals to minus b plus minus square root b squared minus 4ac over 2a. And that's the second method. That's the second method. So in this case, we have something called discriminant. That's b squared minus 4ac. That's what we learned yesterday. Okay, that's b squared minus 4ac. Okay, when discriminant less than 0, we'll have no solution. When discriminant equals to 0, we'll have one solution. And when discriminant is greater than 0, we'll have two solutions, like two distinct solutions. Okay, that's everything we have learned so far. Okay, that's everything we have learned so far. Now I want to put everything together. Okay, so that's different exercise. Well, why we learn factorize? Because we want to factorize it and solve it equals to 0, like solving equations. So when we're trying to sketch, later we learn how to sketch, and when we learn how to solve, we all need to factorize first. Okay, factorize is a really helpful way to do things. Completing square and factorize, there are two different ways to sketch and to solve, and quadratic formula is another way to solve. So now I'll put things together. So what I will do is, because factorize is, well, if you want to solve, then you need to factorize. I can combine things together. So what I will do is, solve ax squared plus bx plus c equals to 0. You know I have three situations. I have two distinct solutions. I can have one solution. I can have no solution. Okay, that's the three different cases. I'll write this a little below. So two solutions, one solution and no solution. Okay. After that, I have two methods to do that. One method is quadratic formula. which is x equals to minus b plus minus square root b squared minus 4ac over 2a. Okay, that's the first thing we have. And second method I can use is factorize. Okay, we want to use factorize and then non-factor law. Okay, we can use both methods, like factorize and use non-factor law. So two solutions is very easy. Two solutions means we call something discriminant. Discriminant equals to b squared minus 4ac, and discriminant greater than 0 give you two solutions. Discriminant equals to 0 that give you one solution, and discriminant less than 0 that give you no solutions. That's the three case, very easy from the quadratic formula. We can just find the values. If we talk about the factors, okay, if we talk about factors, I'll split that in another column here. So two solution means we have two distinct factors. Okay, I just don't write the distinct. So we have two distinct linear factors. So for one solution, it means is a perfect square, and its repeated factor, which is ax minus h squared, like repeated factor. Okay, x minus h times x minus h. Don't worry about the a is just a coefficient. You can divide it as well on everything when you solve that equals to 0. And no solution means cannot be factorized. So in which case it cannot be factorized? You know, is ax minus h squared plus k when k greater than 0. That's the case you cannot factorize it. Okay, cannot be factorized. It means plus k, like, which means you cannot factorize it. So when we have two factors, like when you have two factors, I'll write that in red. Okay, that's the three forms. Ax minus h squared plus k, that means cannot be factorized. If you have ax minus h squared minus k, which means you can factorize. Well, when you have ax minus h squared, there's no k value, that means only one solution. This row, like this column, shows completing square. Okay, this is the method for that is the completing square. And for those two, perfect square and the two distinct factors, I can also factorize by cross multiplication method. But only part of the quadratic can be factorized by this method. Okay, so that is what it looks like to connect everything together. Okay, so we want to talk about the number of solutions for a quadratic equation. We can have two solutions, one solution, and no solution. And for two solutions, okay, so for two solutions, which means you have two distinct factors. And that one, okay, look at the horizontal row, they all talk about the same thing. When the discriminant greater than 0 means the thing can be factorized, and it can be factorized by two distinct factors. When you have one solution, which means discriminant equals to 0. When discriminant equals to 0, that means you have a perfect square and you won't have the k value. When your discriminant is less than 0, it means you have no solutions, but it also means it cannot be factorized. And when you complete square, you should have a plus k there. Okay, they're all the same thing. In the same row, they are the same thing. You get one, you need to get the other two as well. You need to get the other two as well. And then, like, cross multiplication is not really something very powerful. It can only do part of the things. Okay, it can only deal with the quadratic can be factorized. Well, I can't really say this quadratic cannot be solved or factorized by cross multiplication. Therefore, it cannot be factorized. Like, I can't make this conclusion. I can just say cross multiplication method can only deal with the thing can be factorized. And part of the thing can be factorized, can be done by that method. So it's a very small proportion. If you think that like as a Venn diagram, so we have a thing, and then we say in this circle, is the quadratic can be factorized? Okay, this circle is the thing can be factorized and can be done by completing square. Okay, it definitely can be done by completing square, but only part of the thing here. Okay, part of the thing here can be done by cross multiplication. Or like some of you may use grouping, but they are the same method. And then the rest of it is the cannot be factorized. Okay, the rest of it is outside that circle. It will be cannot be factorized. So overall is ax squared plus bx plus c. Okay, so all the quadratics is this rectangle. Like everything is this rectangle. So that's the full set, and it be split into two parts. Can be factorized, cannot be factorized, and in the can be factorized, like everything can be done by cross multiplication, completing square, and another section inside that will be done by cross multiplication. That's the relationship between all this method. Okay, don't worry about like if you can't copy down everything. I will save this page and upload that with the notes together with you, so you can see this page. I can export that. You can check online. I don't know. I don't think you can use CAS because CAS can factorize that directly and completing square directly for you. I think it should be no CAS. Well, I'm not sure about. I think normally if it's no CAS, then there's no nose.
We get a formula.
No. That's what you need to remember. Well, just show you for the calculator. Just pick something. Let's pick. That's year 11, not yours. Wait, where's your nose? Okay, that's your nose. Okay, let's pick a question. For example, that one. Okay, 2x squared minus 2x minus 3. Okay, 2x squared minus 2x minus 3. I can do three things. I can factorize it. I can complete square. Well, I can complete square and I can complete square then hand approach to factorize, or I can complete square. I can okay, so I can do completing square, and then factorize by myself. Or I can ask the calculator to factorize it for me, and then I use non-factor law. And then I can directly solve it in the calculator. Okay, I can factorize by the calculator and then solve by hand, use non-factor law. Well, this is non-factor law after that as well. Okay, I can complete square. Well, these three, it can be done by CAS. Okay, these three can be done by CAS. For quadratic, I can complete square and then factorize by myself and then use non-factor law. Or I can directly factorize by the calculator and then I use non-factor law. Or even easily, I can directly use the calculator to solve it for me. Okay, number 3 is easy. Okay, so I can go menu number 3 and number 1, get the solve. Menu 3, 1 to solve. And then I got 2x squared minus 2x minus 3 equals to 0. And then comma x. Okay, comma x means I solve for x. You can have a, b, c, and x all in one equation, but x is the variable. Then the calculator will treat a and b as a constant and then solve it in terms of a and b. So when we do that, we have the answer, exact answer. Okay, so minus root 7 plus 1 over 2, root 7 plus 1 over 2. So it should be the same as what you did yesterday. That's the first method. Or I can go menu 3, algebra, and I can go factor. Where is it? Menu 3 and 2. Okay, factor. Okay, I can type the same thing in. Okay, do not include the comma 0. Just type the function in and press comma x to indicate what is your variable, and then press enter. It's factorized for you. Okay. If you write a half times 2x plus root 7 minus 1 times 2x minus root 7 minus 1. That's the factor. Well, don't worry, it might be a little bit different from your notation, but it will be the exactly same thing. Okay, it will be exactly the same thing. So that one is a half times 2x. Calculator sometimes do like a good looking form, like it looks better than what you did. So, but it's alright, this will give you the same answer. So it's a half times 2x plus root 7 minus 1 times 2x minus root 7 minus 1. Or I can complete square by the calculator. So menu number 3 and C, completing square, complete square, press that. Still copy the same thing, in exactly the same thing into complete square, and it completes square for you. Yeah? Good. Looks nice. But you need to be aware of that. After you do this, okay, it completes square for you, right? So showing you the complete square is come down. So the answer is 2 bracket x minus a half squared minus 7 over 2. But you need to be careful. This is not in the a squared minus b squared form, because of the coefficient 2. This 2 is not squared yet. So if you want to factorize that further, what you need to do is you need to take this 2 out as a common factor. You have 7 over 4 here. Okay, you need to take 2 as a common factor. You need to take 2 from 2 terms. And then what you have is 2x minus a half squared minus root 7 over 2 squared. Now is a squared minus b squared. Okay, now is a squared minus b squared. Because if you treat this as a, 2 is not squared. Yeah, you can square root that, no problem. But this number is not squared for. You only squared this, but it hasn't squared the 2. So that doesn't work. Okay, that doesn't work. So you need to take 2 as a common factor. Okay, get 2 out, like I don't need this 2. And then I only see the other 2 terms in the bracket. And then what I will have is 2. Then in this bracket, what you will have is x minus a half plus root 7 over 2 and x minus a half minus root 7 over 2. That's the after completing square, and I will factorize by myself. Okay, complete square and then factorize by myself. When you have a coefficient a, that's the time you need to be careful. You need to take the a as a common factor first from the 2 terms, and then complete square, factorize by yourself. Questions? So 3 functions on the calculator. You can solve it, you can factorize it, and you can complete square for quadratic. Okay? Solve, factorize, and complete square.
Wait, is that question, so like, would it, if it said factorize this, that?
Yeah, that's the factorize form.
That's how to do it?
No, like if you just want to factorize and if you have calculator, factorize form is above. You can directly factorize. Yeah?
Yeah, but like, okay.
What's your question again?
I don't really know.
No, I just show you can complete square that by calculator and you can further factorize.
No, I'm not talking about the calculator. The other thing you just wrote.
Yeah?
Is that so would it have said factorize this?
Yeah.
And that's, okay.
Yeah, that's factorize. For example, the question is factorize that.
Okay.
And then that's the factorize form.
Yeah.
That's what I just want to show you. You need to be careful with that too if you want to do from the completing square form and to factorize it. Yeah. Okay, any questions for this one?
Maybe just stay on that.
Done?
Oh, yeah.
Okay, everyone. Just go to page 7. Okay, page 7, I don't need to really Okay, for page 7, I don't really need to go through single questions. Like, we use the method to solve for quadratic, but before we solve the quadratic, we need to set up equations first. Okay, I need to set up the equations for all of these either wording questions or by giving you the diagram. I need to set up like the equation and solve equations. It's just like we use algebraic way to solve application questions. So, for example, the first one, if the area of a rectangle is fixed at 28 meters squared and its length is 3 meters more than its width, determine the dimension of the rectangle. When I say dimension of the rectangle is ask you what's the length times width. Okay, you need to answer the length and also the width. And if it's a 3-dimension shape, you need to answer the height as well. So it needs to give you all the measurement values, the length, width, and the height. Okay, if there's other measurement values, you need to answer that as well. So the area of a rectangle is fixed at 28 meters squared. So I just draw any rectangles, and I have 28 meters squared for that one. And I have my width is width, but length is width plus 3, because length is 3 meters more than the width. So if I have my width is W, then the length will be W plus 3. But I don't have W in the question. I need to define what is W. So the first sentence you need to write is let W be the width of the rectangle. Okay, let W be the width of the rectangle. Then length will be W plus 3 meters. And then length will be W plus 3 meters. So W plus 3 times W. W plus 3 times W, that gives you 28. Or if you don't like W, you can put X. Okay, X is the normal variable. You can put X. X times X plus 3. So length times width should give you 28. So we can expand W squared plus 3W minus 28. That equals to 0. Okay, we can cross multiply that. 1, 1, 4, and 7. I need a positive 3, so I need a negative 4. So W minus 4 and W plus 7 give you 0. W minus 4 times W plus 7, that give you 0. So W equals to 4. Or W equals to minus 7 by solving by 9-factor law. Can I take both of that? Which one I can't take? Yeah, like its measurement values, I can't take minus, so I need to reject that. But when you answer the thing, you still need to write it. Like you need to write exactly like what I did. So you write that, and then you better say reject, like reject. Okay, you write that down and then say you reject that. Because negative. Like if you want, you can put some explanations. If you don't want to, that's fine. We know that measurement value can't be negative, so that's why you cross that out. So the width is 4, the length will be 7. Okay, so you have answered, you need to answer the question that the length is 7 and the width is 4 meters. Okay, so 4 times 7, that gives you 28, and length is 3 meters longer than the width. So they all satisfy. Okay, all the information satisfy. Okay, for example 2 and 3, I'm not going to solve it for you. I can ask you to solve it, but let's just set up the equation together. For the second one, what equations you can set up? You can do Pythagoras, that's true. So what to do? How to do Pythagoras? A squared plus B is that squared equals to 10 squared. And then you can expand everything, simplify, and then solve for that. Okay, we don't have enough time. I'll just leave you to solve for this one like next period, like tomorrow, Friday lesson. Let's have a look at example 3. Okay, I'm not sure if you still remember this type of question. That's one of the questions in your exam. Okay, and I feel like a third of the class can do it, and then 2/3 can't do it. You can't set up the equations. I think it's exactly the same type of questions. Talk about father and son's age, or mother and daughter's age, like something like this. It's like you have a relationship now, and after how many years you have another relationship. So what's the method to do this type of questions? You can set up a table easily. So I can set up a table. You have father's age. And you have son's age. You have the age for now, and then another time is in 20 years. I think in this question is talk about in 20 years. So let's set up a table. Like it's clear, okay? It's just show you very clear values and relationships. Okay, A father's age is the square of his son's age, x. So son's age now is x. How you can represent father's age? X squared. Okay. So in 20 years time, okay, don't worry about like what's said after that. So in 20 years time, what's son's age? Can you represent any x?
X plus 20.
Yeah, x plus 20. How about the father's age?
X squared plus 20.
X squared plus 20. Like it's just after 20 years, just age plus 20. And then you keep reading. The father will be 3 times as old as his son. So what equations or what relationship you can set up for me?
X squared plus 20
X squared plus 20
equals 3x.
bracket x plus 20. Okay, bracket x plus 20. So 3 lots of that will give you the father's age. So that's the relationship you need to set up. You can use the same table and go back to the questions for the exam and then try that again. Okay, you really need to get this question right. It's not that hard. We did one in the linear and then we do another one in the quadratic. So go back to your exam paper and then redo the question by using this table. It will be really easy to deal with. Okay, in 20 years time, it's everyone's age plus 20. You don't need to talk about the relationship after that. It's just everyone's age plus 20 from now. And then you read the relationship, how many times of the son and the father. Any questions for that? No? Okay, so you solve for that by yourself. Let's look at the next one. Okay. The height of a golf ball is given by h equals to minus x squared plus 100x, where x meters is the horizontal distance from where the ball was hit. Okay, so I hit the ball flies. Well, can you imagine what the ball looks like? The ball should go like this, right? I hit it from the ground and then go up to the highest point and then go down and drop to the floor, like drop to the ground. I don't need to think about the shape of the equation. I haven't talked about the shape of the equation. Just talk about how the golf ball is hit and then in the air and how to hit the ground again. So that's the shape you should have. That's the path of the ball. And then find the values of x when h equals to 0. There will be 2 points h will be 0. Originally, t equals to 0. Just hit, okay, before you hit it, time equals to 0. And also the time when the ball hit on the ground. So I will solve minus x squared plus 100x equals to 0. I have a question. Can I divide x on both sides now? Can I divide the x on both sides? Like can I do this? Why not? No, I divide both sides by x. That's fine.
You can't have 0 divided by.
Okay, it's not you can't have 0 divided by 0. It's you don't know whether x is 0 or not. You can't divide something when you're not sure about it. Like x can be anything, right? Like x might be anything. Like x might be 0. So you can't divide the 0. You can't divide something you don't know whether it's 0 or not. You need to be definitely sure this can't be 0, then you can divide. Otherwise, you can't. So what we need to do is we need to factorize. So we take minus x as a common factor. And then we have x minus 100. And then we can see x equals to 0 is one solution, or x equals to 100 is another solution. if we divide 0 on both sides, we lose one answer. We only have the answer 100. We won't have the answer for 0 because the x disappeared. So we will have x is either this equals to 0 or this equals to 0. Right? It's either x is 0 or x minus 100 is 0. So we have x equals to 0 and x equals to 100. Interpret your answer from part A. So x is 0 is when you hit. Is originally on the ground. Okay, so the ball sit on the ground, that's not traveling yet. Okay, traveling to nowhere yet. It's just when you hit. And when x equals to 0 is travel 100 meters in horizontal and hit the ground. Okay, it's traveling 100 meters in horizontal and then hit the ground. So that's when x equals to 100, h equals to 0 means. C. Find how far the ball has traveled horizontally when the height is 196 meters. Okay, when the height, so when h equals to 196 meters, what's the horizontal distance? So I can just make minus x squared plus 100x equals to 196. And I can solve by x squared minus 100x plus 196 equals to 0. No, I move everything to the right. I want a positive x squared. Like I like a positive x squared. I like 1x squared, I like 1 positive x squared. So I move everything to the right. You can solve that by yourself after this. You choose why I don't solve it with you, because I want you to pick your own method to solve for it. Like you can use completing square, you can use quadratic formula, you can use directly cross multiplication. See which one will be easier, and then that will answer the question yesterday you asked me why we learn other methods if we can do quadratic formula. So you can have a feel of it, like you see which one is easier and which one is quicker. Okay. Let's look at the last one. A small rectangular block of land has a perimeter of 100. Okay, so perimeter equals to 100. And the area is 2 to 5. Find the dimension of the block. Okay, if I let the width to be x. Okay, here is x. What is your length needs to be in terms of x? What's perimeter? 100? Okay, what's perimeter consists of in this case? 2 length plus 2 width, right? What's the length plus width? What's 1 length plus 1 width? 50, right? 2 lengths, 2 widths is 100. 1 length, 1 width will be 50. So the length will be 50 minus x. Okay, 2 lengths plus 2 widths is 100. 1 length and 1 width is 50. So length is 50 minus width, and that's 50 minus x. Then I can set up the equation as length times width equals to 2 to 5. Okay, length times width equals to 2 to 5. Okay, when you finish, you can leave and you can solve that in Friday lesson.